So let's begin with our module 6. So our topic for this module is on curvilinear motion, normal and tangential components. So later we'll be discussing what is this normal and tangential components. Okay, so here, if you can see the objectives, nag-ingon nga, acknowledge the normal and tangential components of the velocity and acceleration in curvilinear motion. So if you recall, in the projectile motion, we have the x component and the y component of the velocity. So in the curvilinear motion, we do not use the x and y component, but rather the normal and tangential component. And later on, we will discover why we use these normal and tangential components instead of the x and y component. Okay, so here, nasa gingon diri no? So this is somehow related to projectile motion, the curvilinear motion, but it is more general and we call this curvilinear motion. So projectile motion is actually curvilinear motion. So okay, so curvilinear motion differs from rectilinear motion such that the latter involves curved paths, not straight lines. So actually, ang curvilinear motion is involving curved paths. Ang rectilinear motion is straight lines. So we are going to simplify our study of curvilinear motion by describing this motion using two axes. So like the projectile motion, natay duha ka axes, no, x and y axis, or the horizontal and vertical component. Here in the curvilinear motion, we have the n and t coordinates axis. That is the normal n and the tangential t components or axis, which act normal and tangent to the path respectively. Okay, so what is this normal and tangential uh, components of the particle? So, diba atong giingon nga same ni siya sa projectile motions, but here we do not use the x and y component, no, horizontal and vertical component, because the object is not traveling along the awang uh, di lang siya ingon nga ingani iya ang pagbiyahe. So this is a, let's say, a parabolic particle. So in the projectile motion, we use diba natin x component and the y component. But in the curvilinear motion, we we understood the particle as moving in a curved path. Yes, it has a curved path, like this one, like a parabolic one. But here we consider that it moves somehow like a circle. So we can say that this particle until such point is moving or behaving like a circle. So mo ni siya sa curvilinear motion. So sa curvilinear motion, dili lang muna siya along sa katong x and y paana nga movement. So pwede po siya horizontal nga rotation, or let's say it can be also vertical. So para since sa horizontal nga pagtuyot niya wala man te horizontal vertical component, that's why we use the normal and the tangential axis. So normal mean ganitag normal, let's say sugod sa ta sa first. Sa tangential, di ba, earlier I already talked that velocity is always tangent to the curve or to the path of its movement. So mana siya. Let's say this is the velocity. And then this is the point of origin. We use the letter O for representation. So, di ba natin yung nga tangent and normal? So, this is the tangent nga velocity. So, ang velocity, so ang acceleration sa curvilinear motion, napunta duha ka acceleration. Di ba? As mentioned natin, normal and tangential velocity. So, napunta normal and tangential acceleration. So, the tangential acceleration, so maman siyang tangent velocity, same gyapon siya og direction ni ni velocity si acceleration. So we use a sub t, no? That is tangential acceleration. Normal acceleration, so mo siyang normal acceleration. It is towards the origin, towards the center. So we have the symbol acceleration a, but sub n. So the normal acceleration is normal to the tangent line. So when you get normal, it forms a 90 degrees angle. Okay? And so, since namatay do ka component sa acceleration, it means naa di ay direction ang acceleration. So which is like this. We call here the magnitude of the acceleration, or man siya diri ang acceleration, man yang movement. Okay. So if you can see the acceleration, so kung natay tangential acceleration is sub t, and then we have the normal acceleration, so that is 90 degrees. So ang movement the acceleration is something like this. So this is a right triangle. By Pythagorean theorem, we have a squared, the acceleration, is equal to the the square of the tangential acceleration plus the square of the normal acceleration. So we have that a is subtracting into square root on both sides. We can have the acceleration, this one, which is equal to the square root of the square of the tangential acceleration plus the square of the normal acceleration. Okay, now let's get going with the module. So, yun diri nga, a particle is moving along a curved path as shown. So, na example diri. At this instant, it has a radius of curvature rho. So, ang atong gigamit diri, no, dili lang ingon nga r, but we use the rho symbol. So, the rho denotes the radius of curvature. So, with respect to O. So, the O is the origin. This radius of curvature changes unless the path is a circle. So, na certain time ana nga ang kaning rho is the same. Na certain distance. And then, pag abot diri mo change na pod. Okay? It remains constant kung circular lang ang motion. So, di ba, radius. So, it remains constant if circular ang motion. At this instant, the velocity always act tangent to the path. So, if this is the path, ang velocity always act tangent. So, motong giyon ganiha. So, if tangent ang velocity, di ba napunta tangential acceleration? So, same sila og direction ni velocity. Si tangential acceleration. So we are going to denote it with a unit vector. Kani siya, u sub t. So, yun saan ang u sub t? So, giingon diri no nga unit vector. Mura siya unit, no? It just tells us kung asa ga lihok ang where is the direction of a specific magnitude. Okay? So, natay u sub t. So, u sub t denotes tangential mo ng t. And this italicized v is equal to the rate of change of position. Okay, so mo ni siya ang velocity nato, di ba? Kata ang tangential. So, if you remember, di ba? Velocity is just equal to ds over dt, di ba? So, we call this the rate of change of position. Mo nang giingon diri. But here in the curvilinear motion, mo na nin atong ginagamit nga symbol, no? Velocity, this one, is just equal to this. Nu u sub t. So again, this has no value. It only denotes the direction of the velocity. So it means the velocity is moving along the tangent of the path. Muna siyang u sub t. Or we just can simply use v. And then, okay. As for the acceleration, so this is the velocity. So, kani siya is unit vector. It just tells us that the velocity is moving tangent to the path. So, this is just the same velocity. So, mo ni siya ang velocity. As for the acceleration, it has two components. So, ang acceleration natin two components, the normal and the tangential. So, the normal component of acceleration acts towards the radius of curvature, while the tangential component on acceleration acts tangent to the path. So, matong giingon nimo nung ang tangential acceleration, same og direction ni velocity. So, mo ni siya, kung mo makita ang drawing, na diri si, mo ni direction ni the tangential acceleration. Si normal acceleration is normal or perpendicular with tangential acceleration, and then paingon ni siya sa radius or sa origin. So mo ni siya ang normal acceleration. And then we have the acceleration gyud as a whole sa particle. So by vector notation, di ba naman tayo vector and scalar nga quantities. Scalar quantities has magnitude but no direction. So in this in this topic natin may encounter nga acceleration nga magnitude lang atong gipangita with this one, that is a scalar quantity. Kani siyang gipakita diri, this is the vector acceleration. So inyong makita na a sub t, u sub t, and then plus the a sub n, u sub n. So kani siya, di ba, denotes the tangential acceleration. So acceleration sub t, di ba? So it denotes tangential. A sub n is the normal acceleration. So kaning u sub t and then u sub n, ano mong kalibog ana, is just a unit vector. Nagpakita lang ni siya nga kani siya is tangential, kani siya nga value is normal. So nganong kuan man siya, so this is the vector nga acceleration. So nganong kuan man, nganong na may ut ug un. It is because let's say pwede man ta moingon gyud nga tangential acceleration is 2 meters per second squared, and then normal acceleration is 0.5 meters per second squared. So kay mo nang isulat into something like this, the vector acceleration gid niya. So saan na ito pag-determine nga tangential ni siya og normal? So we use these symbols. So 2ut plus 0.5 u sub n. So mo na siya. Kaingon na ta, mo na siya ang tangential acceleration. It is because of this unit vector nga u sub t. Kaingon ta nga ni mo ni ang normal because of the unit vector u sub n. Okay? So mara ni siya. So this is the vector nga acceleration. Okay? So how about this one, sir? A sub t or tangential acceleration is equal to nasa nu, then nasa dot sa ibabaw. So if you remember, di ba ang kani siya nga symbol is the velocity, na i-dot sa ibabaw acceleration, tangential acceleration. Pero na kanin ninyo problemahin because di mo gid kay tayo nga magamit. Ani more likely we use the symbol a sub t or tangential acceleration. And then so this is just a representation. So ato apong normal acceleration, a sub n is just equal to kani siya, square of the velocity over the radius of curvature, si rho. So ay kalibuga kaning v, ano siya, si v, kani siya nga v. This is the velocity. So familiarize kani siya nga v ug kana same na sila. Kani siya si rho, which is mura na siya r sa Greek alphabet, which denotes the radius. So tangential and normal acceleration. Now this is a scalar nga quantity. So katong giingon ako ninyo, no, scalar ni siya nga acceleration. Or it gives only the magnitude. So that's why we have here the magnitude of the acceleration is given by this equation. So katong gipakita na ko ninyo ganiya nga acceleration, magnitude of acceleration is equal to square root of kani siya. Square of the tangential acceleration plus the square of the normal acceleration. So dagan-dagan ang mga formula na dugang. So, ang katugya pong constant acceleration nga problem nato or katong non-constant acceleration equation, we can use in these problems sa curvilinear. So, na nadugang nga formulas. And then, the radius of curvature, sa inyo nakita no, katong radius ani niya, rho, mo yung formula. If nata equation, pero kung ata equation nga given ay paglisod-lisod sa imong kinabuhi. So, rho is just equal to quantity 1 plus, so dy over dx is first derivative, di ba? So that is y prime square raised, kanina din sila gi-raise into 3 halves all over the second derivative of the function. Okay? So this is the Leibniz notation. If we wrote that in prime notation, we can have the, di ba, natin rho is equal to 1 plus dy over dx, or the first derivative, the square, then kani sila is raised to 3 halves over the second derivative, d squared y over dx squared. So in prime notation, we can write that as 1 plus y prime squared raised to 3 halves over the second derivative, y double prime. Actually, this one, ato pa ni siyang matransform. This is, if you see, naatay 2 nga, this is a, kung ano man siya, naka-fraction nga exponent. Kaning 2 denotes a square root or root. So, we can also write this one is into like this. 1 plus the square of y prime. And then, square ni mo sila. And then, square root. Sorry, this is cube. This is cube. And then, square root all over y second prime. So, these are all just the same. Depende lang ninyo kung asa mas dalian ninyo. Okay? So, magamit na ni siya pag na-ay equation gihatag for radius of curvature. Okay. So, let's